Yates continuity correction. The chi-square test may also be unreliable if the number of degrees of freedom is 1. This occurs when we have a 2 by 2 contingency table. So instead, we can use this formula. So let's look at an example. 150 people were asked their age, and I know this is the wrong there. And if they mainly used Facebook or Snapchat. The results are listed below. So again, you can't use quantities unless you group them. So we have people 0 to 25 years old, 38 use Facebook, 58 mainly use Snapchat, 26 to 70, 32 use Facebook, 22 use Snapchat. Okay, and this was just a random quiz. And what we'd want to do the old way, we would find the expected. So the expected values are row total. So the expected for young would be 96 times column total, 70, all over the total, which is 150. Okay, and we would have an expected value of 44.8. That means that if there was no relationship between your age and which social media site you prefer, we would expect, upon surveying these same type of people, same number of people, 44.8 people that are young that use Facebook. Okay, so we could get that for every spot. Let's go ahead and use a calculator to do that though. So I'm going to go to second matrix, edit, and in matrix A it's 2 by 2. I'm going to put 38, 58, 32, 22. Okay, second quit. If I want to make sure I have it right, I can go back into matrix A and look at it. There it is. Now we go to stat, tests, and it's a chi-square test. Not the goodness of fit one your calculator might have. And we put our observed in A and we want it to spit out our expected in B. And we tell it to calculate. Okay, and so if you look over here, it gave us a chi-squared value of 5.38, an approximate p-value of 0.020. Oops, let me scoot this over so you can write it in. And a degrees of freedom of 1, and that comes from doing the number of rows minus 1 times the number of columns minus 1. Okay, but that value is not actually that accurate because of the degrees of freedom. Okay, so instead we could do Yates. And before we do Yates, let's see what we would do if we were doing this at 5%. Okay, this is from that little column, 5%, 1 degrees of freedom. We say if our calculation is greater than that, so our chi-squared calc. Okay, so remember, if our chi-squared calculate value, which we got at 5.38, is bigger than our critical value, which was the 3.84, so in our case, it is true, 5.38 is bigger than our critical value, I'm going to reject the null hypothesis. Okay, the age and social media site preference are independent, which means more likely your age has something to do with which one you prefer, which we all know younger people tend to use Snapchat more than Facebook. Okay, the p-value part of this is if our p-value is less than our significance level, we reject. And in this case, our p-value was 0.02, which happened to be less than our significance level of 5% or 0.05, so it's the same result. And it'll always be the same result. It's just that IB won't make you use the table anymore, they'll make you use the p-value. Okay, but if you were using Yates, you would have to use a table because you don't know how to find the p-value given the chi-squared. So here's what Yates does. The formula changes it, and it has us not only take the difference between the observed and the expected. Oops, I moved it over here. Okay. It then has us subtract 0.5 before we square everything. The regular formula is just the sum of the observed minus the expected squared all over the expected. That's the regular. So the difference is they have you subtract 0.5 first and take some absolute value. Okay, so we're going to do that. So what we did was we put our observed data in this row and our expected data in this row, and we follow the formula. So it says take the observed minus the expected. 38 minus 44.8 is negative 6.8. It then says take the absolute value of that. Okay, that's normally where we would square it. Instead, we're going to take the absolute value and subtract 0.5, so we get 6.2. Now we square it and get 38.44, and then just like before, we then take this 38.44 and divide it by our expected value, and I got 0.85804. And you would do that for the whole table. And notice that my new chi-squared value, this is my Yates, and I'm sorry, I still have a bad stylus. My Yates calc is that. So it's the one that's been corrected, and it's supposed to be a little more accurate. It's saying the difference between what we observe and expect is just a little smaller. We were saying the difference was, an okay difference would be anything smaller than 5.38, and they're saying no, an okay difference would be anything smaller than I lied. Not anything okay. We're saying the difference we noticed between observed and expected was 5.38. They're saying actually no, it's about 4.47. So there's a smaller difference when you correct for how we only have 1 degree of freedom. Okay, and I actually was able to put this in a calculator, you won't, and I got a p-value of 0.032, which makes sense that our p-value went up as our chi-squared went down. Okay, because what it's saying is the chance of having a difference this small or greater with there nothing being wrong is 0.032, where here the chance is 0.020. In this case, it doesn't actually change whether we would reject or fail to reject, okay, because both of them are bigger than 3.84. I've yet to see one where it changes, but it might, okay, because notice it changed a whole almost 1 point. So if you had just the right set of numbers, it might change whether you accept or reject. Okay. So your job now will be to do that with this story problem. Okay, fill in all the blanks. You can get this from your calculator if you want, or you can do it by hand, but then find the Yates. Good luck.